The Voltaic Pile represents one of the most profound turning points in the history of science because it transformed electricity from a fleeting curiosity into a stable, controllable, and reproducible phenomenon, effectively laying the foundations of modern electrical science. Before Alessandro Volta's work at the end of the 18th century, electricity was mainly associated with static effects produced by friction, such as sparks generated by rubbing glass or amber, which were impressive but extremely limited for systematic study. These forms of electricity were momentary, unpredictable, and impossible to maintain over time, preventing scientists from exploring deeper electrical processes. The scientific context in which Volta operated was dominated by an intense debate sparked by the experiments of Luigi Galvani, who observed that frog legs twitched when touched by metal instruments and concluded that living organisms possessed a specific form of animal electricity. Galvani's interpretation suggested that electricity was an intrinsic property of biological tissue, a life force generated by muscles and nerves. Volta, while deeply respectful of Galvani's work, disagreed with this conclusion and approached the phenomenon from a strictly physical perspective. He hypothesized that the electricity observed in Galvani's experiments was not produced by the animal tissue itself, but rather by the contact between different metals, with the organic materials serving merely as a moist conductor that completed the circuit. To demonstrate his theory conclusively, Volta sought a way to generate electricity without using any biological material at all. This led to the invention of the Voltaic Pile in 1800, a remarkably simple yet revolutionary device composed of alternating discs of two dissimilar metals, commonly zinc and copper or silver, stacked in a vertical column and separated by pieces of cloth or cardboard soaked in salt water or acidic solution, which functioned as an electrolyte. Each pair of metal discs acted as a basic electrochemical cell, and when stacked together, their effects accumulated, producing a continuous and steady flow of electric current. This was an entirely new phenomenon. For the first time in history, electricity could be generated chemically and sustained over time, allowing experiments to last minutes, hours, or even longer, rather than ending instantly in a spark. The impact of this invention was immediate and far-reaching. Scientists across Europe quickly began using the Voltaic Pile to explore electrical and chemical processes in unprecedented detail. It enabled the discovery of electrolysis, the process by which electric current can decompose chemical compounds, leading to the isolation of new elements such as sodium and potassium, and giving birth to the field of electrochemistry. The Voltaic Pile also made it possible to study the relationship between electricity, magnetism, and matter in a systematic way, ultimately paving the road toward later breakthroughs by figures such as Faraday and Ampere. Beyond its scientific applications, the Voltaic Pile introduced a new conceptual understanding of electricity itself, showing that it was not a mysterious fluid tied to life or friction, but a universal physical phenomenon arising from interactions between materials and governed by consistent laws. This shift had enormous philosophical implications, reinforcing the idea that natural phenomena could be explained through experimentation, measurement, and rational models, rather than vitalistic forces. Volta's achievement also had a lasting technological legacy, as the Voltaic Pile is the direct ancestor of all modern batteries, from simple household cells to advanced energy storage systems that power contemporary electronics and electric vehicles. By resolving the controversy surrounding animal electricity and providing a practical method for generating continuous current, Alessandro Volta fundamentally changed humanity's relationship with electricity, turning it into a tool for exploration, innovation, and technological progress, and firmly establishing the beginning of electricity as a true experimental science rather than a collection of isolated and spectacular effects.